Hello. Welcome. I'm gonna be doing some PICO-8 development today, so I figured I would stream it. Thanks for joining or watching after the fact. That's cool too. Um, so what I'm gonna be doing is last stream, I said that I was gonna remake Juggle Panic, this game in the upper right here, but it actually turned into sort of like a beginner's tutorial stream, so that didn't really happen, which was super fun. I think I'm gonna keep doing that, but it was also very slow going for me. I did not get as much development done as I would have liked, and I need over the next week to make this game into something great because I'm going to be presenting it on March 9th at Cloud City, is it, for Death by Audio Arcade, so it needs to be good. So I figured I just need to kind of spend some hours remaking and rebuilding this game, making it better. Might as well do that on stream, so that's going to be the objective today. So for anyone watching, the game itself is kind of silly. It's two players, and you just sort of juggle balls and throw them across and try to catch them, and the first to drop 5 balls loses, and the other player wins. And it's given a little bit additional life in that there are just like random modes that are activated. Like there's bomb mode where all the balls are bombs, and blackout mode where the screen is entirely black and you can only see the balls, and it's wacky and wild, and hey, it's super fun. Or it will be super fun once we rebuild it. So let's just do that. Yay. Player 1 wins, player 2 loses, hooray. And then it resets, and then you can play again. And that's the entire game. So very simple game. I built it in a day, which is why it's so horribly programmed, and I need to reprogram it. I have the code up here, but I think it's probably going to be easiest to start from scratch, because this is really poorly coded. Cart revised P8. Like I said in the other stream, I made an attempt at kind of revising this game in that stream, but it didn't go so well because it just kind of turned into a tutorial, which was super cool. So I'm just gonna kind of like go quickly, go fast, build a game. If you have any questions, feel free to ask. I'm happy to explain, but otherwise I'm just gonna kind of default to going at it. Juggle Panic 2, go into that. Let's save VO1. Take CD Juggle Panic. Did that actually overwrite it? That did. That's okay. I have it saved in Git, so it's not that much of a problem. I just saved over one of my files in development, which isn't too much of a problem. Here, I'm gonna reboot just to fix that. Because I use Git to save all my files externally. It's a good lesson in doing that, so that when that happens, you don't lose a ton of work. So I'm gonna edit the file in my beloved editor Sublime. And I think I'm actually going to steal some code from other games I've worked on. So I want to go quickly. Yeah, we'll do that. So let's go to open a new Sublime. Get you out of there. Let me see the other repos I have, and then we can steal some code from them. I think the just one boss would be, I think that has some code that I want in it. So that has a spawn entity function. I'm gonna steal. Doop-a-doop. That's right. The outline of this though. Function update. Function draw. So we're starting from scratch, which might be fun, except I'm stealing some code, which might be less fun for people watching. But like I said, this is just my time to build a game that I really need to build at some time in the next week. And if you get something out of it, great. If you don't, well, get to spend time with you in a way, so that's good. Class name, local. So right now, in the previous stream, I introduced the concept of like entities and entity classes. I haven't gotten all the way through that yet, but I'm just stealing code that does that right now. It's a very useful concept. Just kind of like taking what I need from another game I made and getting rid of the rest of it. Extends the class dot extends the class dot xy args through. Great. Default counter frames alive. Hurtbox channel. Don't need that. Spatial props x. We need an x. We need a y. We need a vx. We need a vy. Init update draw. That. Draw offset. Nope. Draw sprite. Die. If not, self det is alive. If the entity is alive, then die. Again, this might not make the most sense because I'm stealing from another game with its own context and stuff, but we will be able to promise, don't need promises. We'll be able to kind of use this method without maybe understanding it fully, which is good. Don't need that. Self.that expectation, self.vx, self.vy, move, don't need that. Nope. Frames to death. Render layer is boss generated. Render layer equals 5. What was the other thing? Frames to death. That's a useful concept. Frames to death equals 0. Let me just check stuff real quick. Okay, great. Checking. Make sure streams up, we're recording. Great. Apply velocity. So this method creates an object that has just some very default functions on it. Init update draw that are no op functions that don't do anything. I'll define that no op. It's a function that doesn't do anything. Useful little thing to have on hand though. Sometimes you need to just plug in a method that doesn't do anything. That's sometimes easier than checking to see if a method exists. You can just call update and it will do nothing. Apply velocity. I don't know if we want that yet. Well, we'll see. Add class property methods. The class KV. That here. Local KV. And so for everything in the class, add this onto it. Don't need you. That's gross. A lot of the code that I'm removing is from another game, Just One Boss, that I created that hit like the maximum token limit. So I need to add a bunch of junk that saved tokens, but was really gross. So basically all I'm removing is the super gross stuff that's specific to that game. Add properties onto it from the arguments. Args v, that's good. Entity init, call the init function, add it to an array of entities, return it. Great. I think that's the spawn entity method we want. So I'm basically just setting up like the structure for imagine having an array of entities and then being able to draw and update them all on the screen. That is all this code is doing. So let's do find the update code I had from another game. We'll do it. So get the number of entities to for each of the entities. local I entity. For each entity, you can remove that. Call the entity's update function. Let's do this. Should fly. Should skip velocity equals skip apply velocity equals. Oh god, that's so gross. Let's just do entity update. So we're gonna update the entity, and if the entity's update function returns true, then we won't apply the entity's velocity, which is a if not skip apply then entity apply velocity. Might not make the most sense. That's okay. Sometimes, usually the way game objects work is like if you have a missile, you have Mario, they have an X velocity and the Y velocity in a 2D game, and usually every frame you just add that velocity onto the entity's position. But some objects move a little differently. And like a teleporting object won't have velocity, it'll just go instantly from one place to another. So if the update function returns true, that means that the update function handled the applying velocity step and it doesn't need to do it. Do call each entity's update method. Let's draw each entity to. Oh, right. You draw. Again, I'm just stealing from. Just stealing from another game I have so that I have kind of like a template. Maybe I'll just commit the template so that if you want to make your own games, you have a template to start with. That's what I'll do. So I'll commit it. That way you all have it. For each entities, do entity draw. Yeah, that's it. And the reason I'm not doing a for each loop in this in the update loop, so I'm doing a for each in the draw loop, and I'm actually doing a for I equals 1 to the number of entities loop in the update function. The reason I'm doing that is because when you update an entity, it might create another entity, and I don't want that created entity to be updated immediately. I want to update on the next frame at the soonest. So if you go update, if you iterate from 1 to the number of entities at the start of the frame, it won't update the entities that were added after the fact. So that's why I'm doing that. Let's just draw each entity. Update each entity. Lovely. So that's why that's that way. And I tend to like for each loops because they're just a little bit cleaner and they use fewer tokens, but they use more CPU. So if you're CPU constrained, if you're making a PICO-8 game that has like 4 nested loops, don't use a for each because that will eat through your CPU and memory, probably. What else do we need to instrument this? Let's just see if it's running. Cool, it's running. It's not drawing anything, so you can't really tell. Let's go to draw. Clear the screen, shake the camera, draw the background. Clear the screen, draw each entity. What do we need to do next? We have entities, we have entity classes. That's a good place to start. I'm just gonna commit that. It's like a little starting template for just having entities. See, Juggle Panic. Copy this in cart revised. Commit that. Starting template with with basically nothing in it. Nothing other than entity code. Yep. Origin master. Just post that. The link to that in the chat. GitHub. Repos. Juggle Panic. Cart revised. Lovely. Post it. There you go. Post it in chat. A link to the file working on. I'll be committing regularly. What do we need to do next? We need to have some entity classes, and this is the part where I think it starts to be kind of game specific. Well, we need to do frames to death stuff. So let's do player equals. So this is kind of like my personal workaround for the fact that PICO-8 and Lua, or no, I don't know if Lua does. PICO-8 doesn't have concept of classes. So you kind of need to make your own concept of like entity classes. So if you have like Mario and a mushroom and a Goomba, those can all be thought of their own class of entity. And in my game, there's going to be a player, which let's call them a juggler. Because who knows if they're player controlled? They could be CPU controlled. Ball. There are lots of balls on the screen. There's a ball spawner. And I think those are basically all the entities in the game. So let's do this. When we initialize our game, and you can see it's there's not very much content in this game yet. When we initialize our cart, let's spawn entity. You type in the class of that you're going for, juggler. You give it an X location, a Y location, and then additional arguments, which there are none that we have right now for a juggler. Let's spawn 2 of them. Let's load and run. If the class extends, attempt to carry num with no. Oh, okay. Sure. Extends. There we go. So that's a little bit of code I rigged up to simulate extending classes. Okay, great. So there's no compile time errors or anything like that, but I think it's runtime errors. Yeah, or both. There's no compile time or runtime errors. Hooray. And the reason nothing's being drawn to the screen is our draw method just clears the screen and draws each entity. Each entity has a draw method. That draw method right now is noop, stands for no op, which is no operation, which is don't do anything. So we made 2 jugglers, but they need to have a draw method. And you can kind of see this is why I like this pattern, is it's very easy. It's very easy to see, like, I made jugglers, but they're not drawing. So you go to the juggler's draw method. Let's just pset self.x self.y. 8 stands for red. Run it. We can see our 2 jugglers on the screen. 2 red pixels. So now the jugglers have a draw method. Yay. Let's also rect 0, 0, 127, 127, 1. Let's see the boundaries of our screen so that we can get some context. Good. What do we want to do next? We have 2 jugglers on the screen. I probably want, so 2 things are, I want to be able to draw an actual, so in my original game, let's go back here. Juggle Panic. Load VO7. So in my original game, let's take a little screen cap of that. Whew. Jugglers were little dancing dudes. Juggle Panic. Oops. EDC. 2 load VO1. Okay. So in the original, the first game I made over the course of 20 hours, these little dudes are the jugglers. They have this cute little sprite. I might just reuse the sprite because it is kind of cute and endearing. looks very wonky and silly. They kind of have hook arms, which I'm not too much a fan of. Little hook arms, but hard to get more definition there, considering they're so small. I kind of like that they're silhouetted by the rainbow sky in the background, but maybe that will change too. I kind of like that though, so I think it's probably gonna stay. But they need, so I think a useful concept of this game, entities will need a concept of width and height. So these do this. These jugglers aren't just a point, they're like a rectangle. So that can be stored as an X location and a Y location of the upper left corner, and then a width and a height of the rectangle. And then that's useful for detecting collisions and stuff like that. So I think this is going to be a game. Sometimes in some games, it's useful to have like circle-based hit detection or stuff like that. But like just compare the radii of the entities. But I think this is going to be one where I want width and height for basically everything. Even though there are balls, maybe the balls can use width and height, but we'll see. I think was there height equals 0. I'm gonna add a default width and height on everything. Let's say that height equals 8. Add some width and height to our jugglers, and in our draw method, instead of just setting a pixel, let's do rect fill self.x self y self.x plus self.width self.y plus self.height 8. Great. And then we can see if we change like the width to something thinner, they get visibly thinner, blah blah blah. Doesn't look too exciting right now, but we're just starting out. They are just little red rectangles right now. It will get better. This is a point where I start to get bothered. I like pixel accuracy. So there's this weird thing in game development. Let's just go into this. In PICO-8 game development specifically, or like other game development, yes. But so imagine each of these like gray and dark gray rectangles is a pixel on the screen. So we're like super zoomed in, and let's say there is an entity at like positioned at like x equals, so let's say this is like 0 0, and 0 0 is actually this upper left corner of this pixel here, and 1 1 would be this upper left corner. If I have an entity that, like, let's say it's at 2 2, so it's right here, and let's say it moves 0.1 pixels to the left so that it's right there, that gets drawn here in this whole pixel. But if I have an entity that's here in the upper left hand corner and it moves 0.1 pixels to the right, it still gets drawn in the same pixel. It doesn't look like it moved. So there's this weird thing where by default in PICO-8, if you set something's like X value to 29 or something and it moves to 28.9, it will look like it moved a whole pixel. But if it moves to 29.1, it'll look like it didn't move at all. And I don't like that much. So what I do is, if there's an entity positioned here, I actually add 0.5 to its value, so it's actually right there. And that way, if it moves like a distance left versus a distance right, it will correspond to the same shift in pixels, either 1 pixel to the left or 1 pixel to the right. And you achieve that by adding 0.5 to the value. So I'm going to do that. Plus 0.5 plus 0.5. Let's get this here so we can see it. And then it shouldn't change anything right now. Great. So if we were to make this juggler at like 0 0, you can see that it's up there in the upper left hand corner. If we were to make it at negative 0.7, that move? Did that move at all? Meh, didn't move. Did I do this right? So this is something that I might be a little bit anal about, but I care. I want it to be right. What am I doing wrong? Oh, right. Because it's off the screen. Of course. Okay, cool. Let's make it displayed at 2. So this is what it's like at 2. This is what it's like at 1.9. In the same spot. Great. This is what it's like at 2.1. Same spot again. But a little bit of a trickiness here. I'm looking at the left side and seeing that there's just 2 pixels from the left side of the screen. Good. So 1.9, 2.0, 2.1 are all displayed in the same X value. That's good. But if you might have noticed that when I had it at X equals 2, do this. That work? I believe what's happening is, yeah. So if I have it at 1.9 versus 2, the right corner of it changes, and that's because of we're setting the X and the X1 and the Y1, the upper left corner correctly, but we're not setting the lower right corner using the same method, so we actually need to subtract 0.5, I believe. And I can test that. Let's make the width and the height 1. Should just be 1 pixel. If I set it to 2, it should be just 2. If I have it be 2.1, good. 1.9, good. Do 0.4. Again, this is just something that I like to assure myself of, because sometimes you'll build a game and things look like they're colliding, but they're not. Or they look like they're not colliding, but they are. So I like it to be a little more pixel perfect. It helps make things down the road a little easier to just debug this right now and get it right. Let's actually, how about this? Update function self. Let's add an update method to verify this. Self.x plus equal 0.1. So the big thing is the size of these shouldn't shift over time. 0.07. And they don't. Whereas if I hadn't included this negative 0.5, I think they would, yeah, they do a little cute blobby animation, which is cute. Not what we want. Because I need to be able to tell where my entities are precisely. You just wrecked. Good. Let's put these approximately will they actually be 90, 90, and 80. So the entities will be somewhere down there. I want the entities to be able to move when the juggler specifically to be able to move in response to button presses. So I'm gonna have, and they just move horizontally. So what I like to do is, in the update method, I'm gonna be like, if button 0, then self.move. Alright, let's do this. Anyone here familiar with a ternary statement? My favorite thing. Ternary. Function. Ternary. Copying this from another segment, another file. Let's put it below. A ternary statement is a quick one-line thing where it's like, if basketball, then 5 else 0. So it's like basketball, then turn 5 else turn 0. So it's something like that, but a very easy syntax for it. PICO-8 does have kind of a syntax for it. It would be this 5 or 0, which is a little obscured. It's sometimes I look past that in the code and it's a little confusing to me, so I write a function that does this, and then it effectively does the same thing as this, and it's just a little easier for my eyes to read. They're not exactly the same thing, because you could do basketball and and basketball dot blah or 0. And this would work fine, but this might not work because basketball dot blah is processed before it's passed into the function. So they're not exactly the same, but I like to have a ternary function just so I have a good one-line way of doing stuff. So I'm gonna do self.movex equals ternary button 0, which checks to see if the first button 0 is pressed during this frame's update. 1, -1, or no, 1, 0 minus ternary button 1, 1, 0. Boom, boom, boom. So essentially, what this should do is if the left arrow is being pressed, move x will be 1. If the right button is being pressed, move x should be -1. If they're both being pressed, it'll be 1 minus 1, which is 0. If neither is pressed, it'll be 0 minus 0, which is 0. And then let's set self.vx equals self.movex. I had it backwards. 1 is the right arrow and 0 is left arrow. Boop, boop, boop. There you go. So now they're moving. And the reason I'm doing move x separately is because sometimes if you want like a speed factor, like they move very fast, it's useful to store the direction they're moving as an integer 0, 1, or -1 versus the velocity they're moving, which might be a multiple of that. So I store them separately on the object. But we don't want them to all have the same controls. We want, so let's have button offset equal 0. And we check for self.button offset plus 1. Self.button offset plus nothing. And we can set this one's button offset to 6. Then I should be able to move separate. Oh no. This is not how it works. I thought in PICO-8 it was like button 0 through 5 were player 1, button 6 through 11 were player 2. That's not how it works. I forgot. It's second parameter to player node. 0. Maybe it's 1. It's actually just a second parameter to the button. Self.player num 0 self. And that checks to see if that player's buttons are being pressed. Pressing those buttons. And then we want to set the other juggler's player number to 2. And let's see. Got you. We don't have player 1. Player num equals 0. Yes, there we go. So maybe it would make sense to not even define this. Not even have a default value. So you have to specify it. Cool, so now we have 2 jugglers that move on their own. Lefty and righty. Let's reverse those. There you go. I'm just doing what maps to my keyboard well. Great. We got 2 things that move. And they're being drawn as rectangles that are positioned correctly. Great. So I'm not going to do Y movement, but it's the same thing. Just have a move Y. You set self.vy. And the apply velocity function is what updates the position of it automatically, which is called, as long as the update doesn't return true. Great. What do I want next? I could either do each juggler has a sprite that they're drawn with, or we could use some balls. But the balls, I think, so in the game I made in a day, I had the balls moving kind of like, typically what happens is you have like every frame the ball moves. But the balls started moving really, really fast in the other game that I made, the original Juggle Panic, which means that sometimes the hit detection wouldn't go off. So I think I need to come up with a cleverer way of updating the ball's position. Let's do that. This is a fine time to do that. Width 5. Update function self. Draw equals function self. Let's spawn the ball at 50-50. We don't need to specify any arguments. Let's rect fill. Let's do the same thing. We can just use this. Doop-a-doop. Let's just make this a property on the objects, on the entities themselves. Draw outline equals function self color and self to x plus, because I think color or 8. And this basically, this syntax, if you didn't pass in a color, if this was nil or 8 goes to 8. If you did pass in a color, it would go to color. So that's what that expression is. And that way I can just be like, hey, my juggler, self.draw outline, done. And for my ball, self.draw outline, done. And I added a ball. There's the ball. Yay. It's not a juggler. I can't move it. And then in addition to drawing an outline, let's do circ self to x self to y. This isn't gonna work. Okay. Yes. Yellow. It's the wrong radius. It's the position of the wrong point because we're x and y refer to the upper left corner of the ball. I want it to be at the center of the ball, which is self plus self cut width over 2 height. There you go. It's positioned correctly. Might need to floor that. We will see. And then it's the wrong radius. Right. There you go. It's a ball. So now if we don't draw the outline, you can see that it is circle. We'll do circle. Great. So good. The ball needs to move, so this is where I'm gonna have to consult some math. Let's do some mathin'. Let's check some notifications. Make sure no one's chatting at me. Good. We're all good. Are we? We are all good. What do we need to do next? Math. We need to do math. Doop-a-doop. What's the function for a parabola? So what I'm thinking is I want these balls, they're going to travel in an arc, and I could update them in time steps like I do with my jugglers, where every frame you check to see the move X and you move them that much. But I know my balls are always going to travel in arcs, so why don't I just calculate an arc? They can figure out where they are on that arc and they can set their position there. So they're probably gonna move a little differently, and I think this has the advantage where I think it'll be more predictable for players. Think. So it's just x squared. Yeah, makes sense. Is there a better parabola? No, that's about right. That's what it would be if you threw a ball up in the air and make a parabola. It would do something like that. So, yeah, we'll do that. Let's make sure we can do parabolas correctly. The other cool thing about having balls that fly through the air with a given parabola is I don't need to do the math of like, what's the initial velocity needed for it to travel 50 pixels horizontally and 80 pixels vertically. I can just kind of like, if we get a function for it, then we can just plug it into the function. So I want function that for a given t, time, height, distance gives x, y. So it would be like time, height, time, distance, height, x, y. Doop-a-doop. And I'm writing this in the draw method because I think I want to draw a parabola. Function get parabola. Point. Time, distance. Distance is a bad word. Can't think of another one. Oh well. Return 0, 0. 0, 0. Wait, can you do that? Function a return 5, 6, and bc equals a. Print b. Print a. Oh, c. Oh shit, you can. Neato. I think I learned that at one point, but I forgot. So you can have a method in PICO-8 return multiple values and assign them like this. B, comma c equals a. Gives xy. So I'm just going to do that, and then let's do this. Local. So the reason I'm writing it in draw is because I want to draw the parabola first for I equals 100 do, or let's have it be a percent of the way through the parabola. That's what it'll be. And then we'll do local xy equals get parabola point I over 100, 0, distance 50, height 50. And this is going to be, I'm actually going to need an xy start x, start y. Yes. Whoops. So I want, give me the point at a parabola I percent of the way through the parabola starting at, do x equals 20, y equals 90, going 50 pixels horizontally and 80 pixels. And this will do xy. Load. Boom. Get parabola point. Oh yeah. P set xy 12. A nice blue. Good look. Get it off the player by default. There you go. So I'm gonna draw the parabola, but it's, oh shoot, how are we gonna do this? Because it needs to not be a smooth parabola. Well, we'll see. We'll see. So x, we can just apply an easing function. To the time. Yeah. Okay. Sorry, I'm mumbling to myself. If you want clarity on anything, I'm happy to answer questions, but otherwise I'm just kind of programming at it. Draw a parabola. So actually, x value is pretty easy. Percent times distance. There you go. So that's a parabola that has no height to it. That's going from the left side to the right side. It's that blue line. It's pretty boring. So now we need to do something clever for the height. Might just be, let's do y plus 8. This isn't going to be it. Whoops. Oh yeah. I plus percent. Boom. Nope. Not it. Percent times y minus site. So now we have, this would be a weird ball. This is accelerating upwards. I don't want that. Let's do, what would it be? 5. I could math this out, but I'm just gonna have with it. No. That reduces. Great. So if I wanted percent times percent, okay. Local P2 equals percent minus 5. Just playing, just playing, just playing, just trying to figure stuff out. That's parabola. It's the wrong parabola. Y plus. Great. Let's do this. You set. Let's put a rectangle around where this should be. So it should go from X. It should go from 3100. So the parabola I'm drawing should go from 3100 to 80. The maximum height it should reach is XY. 100 minus 50, 50. 100. Draw that in yellow again. Actually, these are going to be minus 1. Boom. That's the outline of our, let's get rid of our ball. Let's get rid of our jugglers. Get out of here. We're just doing parabola math. Parabola. That's the outline of where our parabola should be. It's not there right now. It's not. Which is sad. Why? Did I do that right? I'm wrong about this. Yeah, that's right. So we want this blue line to curve upwards, reach the top, and then curve back down. That's what we want. Oh, do I need to math it out? So when it's at 1% equals 0.5. When percent is 0.5, y should be y minus height. Yes. When percent is 0, y should be y. I'm talking about this in y. Just say. Yeah, I get it. Percent is 1, y should be y. Minus height. Minus. So we want an expression that is exponential, that halfway through it goes to 1 and then to 0. 0 to 1 to 0. Okay, let's just do this. Get that back here. Oh yeah. 2 times percent minus 0.2. Great. Minus. Nope. Did that wrong. Y minus height plus. Okay. Height over. Well. Height over 2. Well. Look at the expression that is not it yet. Root of 2? Is that it? Root of 2. We can just have this be height over minus 1 plus 2. Local. Doop. Doop. 1.2. 0.6. Okay, is this, what is this number? That's not in there. Not 0.61. Funny little number. Is that it? That's funny. The golden ratio? Is that really it? X. So if I wanted it to go 80 pixels. Percent XY width height. So I'm saying that this needs to go. Am I doing this right? X is 30. X1 is 80. I want it to go 50. I want it to go from 50 to 100. That's wrong. If it's going 80 pixels high and it's starting at X, so it's starting at 100. I want to go 80 pixels high. That means that it should go from 20. So maybe that's why I was having trouble. Yes, it wasn't the golden ratio. I just put in the wrong number. That's funny coincidence. Cool. Looks good. So now let's test it out. Let's say local dist 50, local height, local x equals, do I have it down there? 30, 100. Let's do this. X, y minus x plus dist, y, 12, no, 10. This is me verifying that I wrote a function for get parabola point correctly. Let's see. Actually, we might not need an easing function. I think the exponential handles that just fine. So I think we're good. X, y, dist, height. Yes. Now I can just see. Great. Gonna play with this a little bit. I can scale it around and the parabola does good. Moved it off screen. Let's do 10. Yes. 90. Yes. -10. Yes. Great. We wrote a function to get a point along a parabola. Let's clean it up a little bit. Height. 2 times percent minus 1. Percent times distance. So the distance you're throwing at the height, the maximum height it's gonna reach. This 10%. Nah, I'd like to be. Nah, it doesn't matter. P2. Just gonna plot these in. I don't want to have to name a variable, so I'm just gonna repeat it. Hooray! Great. Get a point along a parabola. Let's do this. Let in some more light. Ugh. It's getting dark and gray over here. That's why we're spending the day programming. Get a point along a parabola. Starts at XY. Moves distance forward. Height up. Upwards. Let's just call it parabola. It's not the best function name, but it'll do. I just kind of want it to be get parabola point. There's so many words in that. Get a point percent along parabola. Gross wording. Get a point along a parabola. There we go. So now let's circle on back to the actual game we're building. Let's have a ball. And let's have the arguments to it. So it already has an x and a y. We need it to have a distance that it's going to travel, 50. Height it's going to travel, 80. And let's say, so we want to have a number of frames that it's going to take to get there. Just do travel frames equals 100. And that'll control how many frames until it hits the ground. And this is kind of like why I want to write this function, so that I can really like control how high the ball goes. Just like if I don't feel like the ball's going high enough, I can just do that. Oh wait, we can't do that. Travel height, because balls already have a height function, a height property. Travel distance, travel height. We can't call it height. There we go. So now ball has all these lovely properties. Do travel frames. Just gonna, sorry, didn't bump. Let's have the init self and self dot travel start x self dot travel start. Let's have it, actually, let's have this be a function on the ball. Ball throw equals function self end. Let's do it like that. I like that better because a ball might exist without moving through an arc. So distance height frames. So let's do local ball equals ball throw, so a ball can throw itself. Could be called ball get thrown, but I'm not going to do that. So throw distance height over 100 frames. Gotcha. And then also, this doesn't happen on a init. This happens. Let's say is traveling through. Let's call it throw, because it's the throw distance, throw height, throw frames. Is throwing, that doesn't make sense. Is being thrown through. And then let's just initialize it being thrown to false. You don't need to do that since it would be initialized to null, which is a falsy value anyways, but I'm going to do it just to be proper. And then this should all be self dot throw height. And then these should be boom. Distance height frames. Great. Bum bum bum. So now we just want to, or let's do throw frames. Do this. I'm gonna run into a problem. Since a ball can be thrown at any point in its lifetime, I'm gonna need to keep track of when it was thrown. So throw duration self dot throw. Or no, I don't want to do that. I want it to be let's call it throw frames. Throw frames equals duration. And then what will happen is on update, if self dot is being thrown, then end. We're gonna actually return true skip apply velocity. Because we're gonna update, velocity doesn't really apply to balls at this point in time. We're just gonna update the position with these variables. And to do self dot is being thrown true. Yes. So then let's do local f equals so let's decrement self dot throw frame minus equals 1. And then do I want Want that to happen. Local percent equals. I want to get the percent of the way through the parabola that ball currently is. So self dot throw frame overthrow duration will be wrong. I'm gonna need to do 1 minus that. Since throw frames overthrow duration, we initialize both the durations, so this is going to be 1, but I want percent to be 0 at the start, so 1 minus 1 will be 0. So that's good. The percent of the way. Well, xy equals parabola self dot throw start x self throw start y. I could have this be. Could have this be a throw. We'll just keep doing it like that. I could unpack the arguments and do an unpacking method, but I'm not going to do that right now. Throw start. We just want this to work. Parabola. Percent x, y, distance, height. Percent x, y. Have to throw, distance. Throw, distance, self, throw, height. Frames, duration, height, distance. X, Y. Yes, we could just have. We don't need do the x self the x throw x and throw the start x and start y. We don't need those to be part of the parabola function. We could just have that be x plus. Just doing it silly. So let's have those not be passed in. Distance, height. Yeah, I think this is the right way. So this is dx dy. Self dot x equals self dot throw start. Oh yeah. So start x plus dx self dot y equals start y plus dy. Do what happens if? Well, let's just run it and see if anything broke. It did. Attempt to formula on global throw duration. Bad me. Self dot throw duration. No problem, game. We're calling throw. Do. Sure. Self dot x. So it doesn't appear to be updating, which is bad. Self dot x plus. See if it's getting in this loop. It is. Self dot throw start x plus dx. So that means dx and dy. Is that true? Looks like it. At position 0, 0, which means that dx and dy have 0, 0. Maybe it's at 1, 1, but I think it's at 0, 0. It's at well, anyway, it shouldn't be constant. Do this at. Oh. Percent is. Oh wait, what happened to my? Whoops! I'm not decrementing throw frame. S equals 1. Whoa! There she goes. Oh, there she goes. Let's do this. Yes. Fly free. Beautiful. Get that back. Let's throw it. Distance, height, duration, distance. Let's move our ball somewhere else. Let's move it to the bottom of the center of the bottom of the. And let's throw it 0, 0. Yep, that makes. Height 20. Ooh. -20. Ooh. Look at our beautiful ball. If I have this, it should go twice as fast. Cute. Yes. Wow. Great. One thing I want to do is I do want to keep this ball's velocity up to date, because no longer moving it via velocity, so velocity isn't really a concept that applies to the ball anymore. We're just moving it by like setting the X and Y position. But I think it would be useful to check in on the X and Y velocity every now and then. So a way to do that is initialize self and self dot and self dot prev x self dot prev y. So a way to kind of, I could figure out, do the derivative of this. Maybe it wouldn't even be that hard. I'm not going to do that though. What I'm going to do is I'm going to store the last position of the ball and the current position of the ball, and the velocity will be the difference between them, if it's being thrown. So let's do this on update 2. This, like that syntax better. X pre-y, xy. We update the x, then update vx equals. So it's gonna be, if it's moving to the right, x is getting bigger. We want the velocity to be positive, so it's gonna be self.x minus self.prev x. Self.y equals self.y minus self.prev y. Previous, that's what that stands for. For frames, if self.throw frames is less than 0, then do I want less than or equal to? I want it to update on 0. Yeah, this is right. Self.throw self dot is being thrown equals false. So now it should stop at the other end. Whoop whoop. Look at that beautiful baby. It should stop at the other end of the parabola now. Good. Good. 100. Go 80 up. Go 30 over. To the right. Woo! Ka-thunk. Good. I'm gonna commit this. Sorry again. Scratch the mic. Bad dudes. Entities. Okay, great. Let's commit that code. Cart revised. Boo boo boo. Clear. Git add all. Git commit. This is me pushing my code to GitHub. Juggle panic. Ball that moves on parabola. Great. Git push origin master. Lovely. So now now we have, well, that's pretty good. That went pretty well. So now we have a ball that actually moves exactly how I want it to. We have 2 little jugglers. That's kind of like we're starting out. We got a good basis for these entities. Is there anything I want to add? I do want to add frames, death frames. Let's take out render layer for now, since I'm not using that. Frames to death, we need to take advantage. Frames to death is basically how I kill things off automatically. Like a lot of entities in games are temporarily lived, like an explosion goes away after, say, 10 frames. The frames to death is a way of keeping track of that. Let's just implement that. Frames to death. Let's do decrement counter. Let's get these in here. Some more helper functions. incrementer counter wrapping to 20k if it risks overflowing. There you go. Decrement counter but not below 0. Boom. Decrement counter property about returns true when it reaches 0. Great. Right, increment counter prop. Counter on a property of an object. And opt. Okay. Okay. K equals increment counter object K. There you go. Counter prop. These are just helper functions that allow me to increment and decrement counters without risking going too far. If you go too high above like 32k positive, then you'll wrap down a negative, which can be bad and maybe screw up a bunch of game logic. Sometimes when you decrement a counter, if you go below 0, it's bad. That's that. Decrement counter on a property of an object. Yeah. What I want here is I want decrement counter prop. Frames to death. So update each entity. We're gonna update it. If decrement counter prop entity frames to death, then so frames to death, this property goes from 1 to 0, then entity die. Sad but true. Death, let's comment that. Wanna filter out dead entity. Whoops. Damn it. There you go. Frames to death, we're implementing that. So if I wanna, let's just go to the update method. I'm looking through another game of mine. Update the timer. Filter out things. Let's get this. This will get this filters out a list. Func. If func item filter out. We're writing a filter function. Local item in all lists. If func not func my complete list. Filter out and which func false. Policy. Well, false. Function of item is false. Do filter local. Yes. And then at the end of the update method, we want to filter out dead entity. Filter entity function entity and that is alive. So now anything that dies is removed from the list of entities, which we can simulate here. Whoops. That seems like I did bad. I did bad. Filter entities function. Return true. Return false. Okay, that's working. So entity that is alive. Right, we're not defining a default. Is alive equals true. Yay. Then let's do juggler. Let's do frames. Death equals 20. Should die in 20 frames. Yay. Hooray! Okay, we got that. What else do we need to do? Sort. Write a sort method. Function. Sort. List. Func. Such a great day. Don't pay no attention. For I equals 1. List. While j is greater than 1 and func. List. List. For each, so this is bubble sort. I think, yeah, this is bubbles. A list according to func. Okay, so for each item in the list, for each item, A is graded. For each item after it. Yeah. Okay, yeah, we bubble sort. This is a bubble sort. Just reminding myself of like the sorting function I implemented and blah blah blah. Could implement this better. That's okay. Spawn entity. Have render layer equals 0. And then let's have in the update method. At the very end of the update method, we're gonna sort entities for rendering. Sort entity function entity 1 entity 2 ent return entity 1 dot render layer is greater than entity 2 dot render layer. How do we test this? Let's put a ball in front of a player, because that's all we got. Now more. So now the ball is rendered on top of the player. This silly because this is just dependent on the order in which the entity initialized. I wanted all balls to appear on top of all players, all jugglers. Then I would just give it a higher render layer. If I give a lower, that goes under. Great, so that's working. I don't know which one I want on top yet, so I won't define it. So now we have render layers that we can make use of too. Render layer equals 0. Well, filter list funcs according to a comparison. Great. Great. Okay. Commit that too. Whoops. Wish I could use get gutter with this, but I'm not actually editing the file that I'm committing when I'm doing this editing. I'm editing the PICO-8 cart file, so setup doesn't let me use get gutter as I'm live programming. So maybe something I'll think about. Great. Clear. Git commit. Adding some default helper methods, implementing frames to death, and render there. Push that out. Great, it's all out there. think I'm gonna end the stream there. Thank you so much for watching. We got, I think, a good solid start to this. We have a little ball that travels along a parabola. The fun little word. We have 2 players that can move side to side. I've posted the link to all this code in the chat, so you can check it out if you want. If you just like copy and paste that file into your own PICO-8, or if you copy and paste that file into a .p8 file and then load that up in PICO-8, should work just the same. So yeah, I'm gonna keep hacking on this over the next couple days. Probably will stream it. So yeah, thanks so much for tuning in. Bye.